Assalamu alaikum. I'm SADIA SAEED. I'm doing my bachelor's in Mechatronics Engineering from University Islamabad. Currently, I am in my 5th semester. Today, I will be explaining simulation of line follower robot along with temperature sensor. Moving on to our problem statement. So, what we are supposed to do here is make a line follower robot which have following 5 features. Our first feature is that it should follow a black line using 3 IR sensors. It is a very commonly used line follower robot mechanism in which there are 2 LEDs, a transmitter LED and a receiver LED. The transmitter LED emits infrared radiation which is received by the receiver LED so that it can detect the black line using this procedure. Our second objective is climate controlled air conditioner system using temperature sensor. Temperature should be displayed on LCD. For this purpose, we are using a temperature sensor LM35 which will give input to our microcontroller which will be displayed on LCD by the second microcontroller as we are using serial communication in this. Moving on to our third objective, motor speed should be controlled using PWM. Rename the left and right motors. We have also to connect LEDs whose brightness will be vary according to the motor speed. Actually, in this task we will use the PWM mode of timers to control our motor speed. Our fourth objective is to make a hurdle detection system. Robot should also have hurdle detection system, which is robot should stop when a hurdle is placed in front of it and start when the hurdle is removed. But the robot should stop and start moving again slowly, not abruptly. And a message should be displayed on LCD when hurdle gets detected. A message will be displayed. In this task, we have to display a message on our LCD that if a hurdle is placed, there should be a message as obstacle ahead. Moving on to our fifth objective. Sensor and motor driving system should be connected to one controller and LCD displaying system on another controller. For this purpose, we are using the serial communication protocol to communicate between the controllers to transfer sensor data or any message to display it on LCD. For this purpose, in our task, we are using SPI communication, and in which one is master and one is slave. We are using 2560 as master because it have more pins so that we can accommodate all the functions and all the sensors. And Mega 328P as slave, which is connected to the LCD and display our functions. So this is our Proteus simulation circuit. In this circuit, this is our Arduino 2650, which is acting as our master Arduino, and this is our slave Arduino, which is at Mega 328P. Starting from with the connections of the slave, with slave Arduino only this LCD contrast is attached with. All the other things are attached with our master Arduino, as the function of slave is only to send data and display it on the LCD. These are our IR sensors. IR sensors, we have used the logic state switches instead of IR sensors. IR sensor give input to the microcontroller, which in turn give input to our motor driver, which drives our motors. This is our left motor, this is our right motor. And then we are having with our 2 sensors, a distance sensor and a temperature sensor. Temperature sensors LM35, which gives the input to our microcontroller, master microcontroller, and which in turn display the temperature on LCD using serial communication. There is a distance simple resistor sensor for distance measurement. These are indicator whenever our robot turns right or left, these LEDs will blink, which is given in our problem statement. This was our circuit, so now we will move on to our code of. So this is our code for our master Arduino. First of all, in this code we have defined our speed of our microprocessor, which is commonly known as crystal frequency. We have used 16 megahertz crystal in our microprocessor. Then we have included all the related libraries. First of all, we have included the AVR library. Then we have included our delay library, AVR delay library. Then we have included our AVR interrupt library, and then our AVR standard library. Then we have defined all our functions which will be used in our code. First of all, we have initialized our Arduino as master. To configure our Arduino as master, we can use this function. Then to send data to the slave, we will use this function, which will be sending data, which will be in character. To send string, we will be using this function. Then we have defined all the pins of our microcontroller. As we are using SPI communications, so we will accordingly define our pins. In SPI communication, we are having with our 4 pins. One is meso clock pin and slave select pin. This is our pin configuration. First one is master out slave input, master input slave output, and then there is a clock pin, and then there is a slave select pin. Slave select pin actually selects the slave to which the data, if we are having multiple slaves, then slave select pin selects the slave to which we are going to have communication with. So this is a data pin configuration of a AVR, and we can say that pin 5 input B, pin 5, 4, 3 and 2 are configured as pins for SPI communication. So we have defined it at 3, 5 and 2 in our code. Then there are functions for PWM. First of all, we will initialize our PWM timer motors to control the speed of the motors. There are 2 motors, so we are controlling the speed of our 2 motors with 2 PWM timers. From this function duty cycle, we will set the duty cycle of our motors, and then this is our function for motors. Then we are having with ADC functions. First of all, this is a function to initialize ADC, and then this is used to control ADC. Then we are using temperature sensor, so we are getting temperature from this function. These are our global variables, we have declared them. Here these are defined pins of our IR sensors. Then this is our function to get distance from our sensor, and these are some global variable which we will be using in our distance function. Now we are moving on to our definitions of functions. First of all, we will be seeing the definitions of our SPI functions. In this function, we have initialized our Arduino as master Arduino. For this, we will be going to our SPI controller register. So SPI controller register have 7 bits. We will start from 7th bit. First bit is used to enable interrupt. Second bit is used to enable SPI communication mode. Third bit is used to configure data order, and then our master slave select. This pin is used to select whether our Arduino is used as a master or a slave. Then here third bit is used for clock polarity, whether we are taking our uh, clock at rising edge or as falling edge. Then second bit is used for clock phase, and our first and 0th bit is used to select the clock rate of SPI. So to configure master, we have to set it as 1. For serial communication, we have to set this bit as 1 and these two bits as 1, as we are using 128 clock select, so we have to set them as 1. Now we will be moving on to the code. This is our code. First of all, we have configured these pin as output. Secondly, we have set it as master. So third one, we have divided the clock by 128, and then we have enable our SPI communication. Our second function is to send data to the slave. We are sending it as by character. If there are multiple slaves, we have to select a slave. To select a slave, we send 0. We clear the bit of that slave. So to clear that bit, we have to low this SS pin, slave select pin. We have to make it low. In this command, we are making it as low. Then we are sending the data to the slave. This condition will wait until the transmission is completed. It will wait here. And after the whole transmission is completed, then we will make the save select pin as high at the end. When all the data is transferred, we have to make the slave select pin high. So this is as we are sending data in characters. So to send a string, we have another function, send string. In this function, this condition will wait. This condition will apply according to the length of our string. If our string is of 5, then it will carry out its function for 5 times, and then it will come out of the loop. Now we are moving on to our PWM function definitions. So first of all, we will move to this function set duty cycle. In this set duty cycle, it is taking in speed as input. If speed is 0, duty cycle will be set as 0, and if speed is 1, duty cycle will be 20. And again, if speed is 2, then our duty cycle will be 50, and if speed is 3, then our duty cycle will be 100. Then this duty cycle value will give output our duty cycle value, and this duty cycle value will be used here in our motor functions. First of all, we have called this function duty cycle set duty cycle, and then the value which we will get, we will put this in formula. So this formula is used for setting the value in output compare register of our desired duty cycle. So these are our PWM functions. One of the function is to initialize the PWM. So this is our PWM initialization. In this function, we have set this base such that it will react every time as it reaches the compare value. Then in these 2 bits, we have set our timer as fast PWM mode. In this bit is set as no prescaler mode. To select our no prescaler mode, we have set this bit as 1. As we are using 2 motors, so we are using 2 PWM. First is from timer 0 and the second one is from timer 1. It is same functions with no scaler mode, fast PWM mode, and here it is setting the register such that the timer reacts whenever it reaches the compare value. So these are our PWM functions. So these are our ADC functions. There are two functions, one to initialize the ADC and second to control the ADC. So the two registers are used, ADMAX and ADSCR SR. So ADMAX is used to select the pin from which we are taking input. Into the block diagram of ADC. This is the block diagram of ADC which is available to us in our Arduino. These are the pins which are available to us in our Arduino, and this is the register ADMUX. ADMUX register is used to select these are the MUX pins. MUX pins are used to select any pins which are used in ADC MUX. These pins are set according to our datasheet, according to the pin which we have to select here. ADMUX have another function which is used to set the reference voltage, and it has an internal reference voltage of 1.1 volt. Then we have to come to this register. This is ADCSR. It is used to select prescaler mode of clock, and these are our output registers. These are two output registers, ADC, ADCH and ADCL. These are two our output register. Then this is our register configuration. These two bits of this register are used to set the reference voltage, and all the bits are used to select the pin to take our input. So this is our ADC mouse. Moving to the code again. So this is our code. For reference voltage we have set it as 1, and these two pins are set to take input from 85, as our temperature sensor is at 85, so we have selected as 85 as our input. Then this is our control function. In control function, first of all we have enable ADC function, and then we have enable interrupt of ADC. These three bits are used to set the prescaler mode of which is 128 mode. We have set ADC in 128 mode. So these are our ADC functions. So our last function is our interrupt enable function. So this is our interrupt enable function, in which we have set two registers. One is master register and the other is control register. These two bits are set such that interrupt occur at any logic change, and this is the interrupt mask register, and this bit is set as 1 to enable the external interrupt of the function. So now, as all the function definitions has been explained, so now we will come to our int main function. The main function of our, first of all we have initialized our Arduino as master Arduino, and then we have called interrupt. In this we are setting all the pins configuration, pin configuration, and then we are having our two variables which will be used later. Next we will initializing our timers as in PWM mode. Then we are having a while loop. In this while loop, first of all we have called the read distance function. Read distance function. So this is our read distance function, in which we have first of all we have created a variable distance function, and then we have initialized our ADC. Actually this is at our ADC pin 3, so we have initialized first of all we have initialized ADC, then we have we have called the control function to control the ADC. So at this command we have start conversion from a digital for analog to digital conversion, and the program will wait here until the conversion is completed. This command will make the program to wait until the conversion is completed, and after that we will clear the flag. ADIF flag is cleared, make it clear, so that it is the indication that conversion has been completed. This is our formula for distance formula, and this is a command ITOA. It is used to convert integer to string. We have called this send string function to send the distance. Then we have called the delay. Afterward, here we have a condition of obstacle. If there is an obstacle detected, then it will send a string of obstacle ahead, and it will be having a delay, and at last it will make clear our LED and stop the report. Here we have called the stop function, so it will stop it. Then we are moving again to our main function. This is our main function. Then we have detected the temperature. For detecting temperature, we have a function get temperature. We are moving on to the temperature, get temperature definition of the function. So first of all, we have, as in the distance function, we have declared a variable. We have declared a variable temp. Then we have initialized ADC control function, and then the conversion has been started here. Secondly, the function will wait until the conversion is completed. Then we have set ADC 5 pin, as we are taking ADC 5 pin as input pin, so we have declared it here. And then as the conversion is completed, we will make clear this flag ADIF. This is the formula for conversion. This is, as you can see, this is ITOA function, which will convert integer to string. As we have given this as 10, so it will convert and give us value in decimal. If we will change it as 16, then it will be giving us value in hex. This will send the data to the slave, and this will send string to the slave. At last, it will clear the LED, and this is our temperature function. Moving on again to the main function. So at last, here we have detected, we have actually, there is a logic of IR sensors. If two IR sensors are on accordingly, then it will turn right, left, or forward. So this was our main function. So at this, our code of master function, master Arduino, is completed, and now we will move on to the code of our slave Arduino. This is our code for slave Arduino. We have started this code, and as usual, we have first declared our AVR library, then we have defined the crystal frequency, then we have declared the library for delay of AVR, then we have included another library, which is LCD library. This is our header file, which we have included by ourselves to declare, as we are using the functions of LCD, so we have declared this header file. Then we have defined our only pin which is used in slave, which is pin 4, as you can see in this. This pin 4 is enabled. For master, pin 3 is enabled, and for slave, pin 4 is enabled. So this is our pin configuration for. Then we have come to our int function. Int function is, so this is our main function, in which we have firstly initialized our LCD. Let's go to the header file of our LCD. In this LCD header file, we have declared port D and port C. From port D we are displaying the data, and from port C we are controlling our LCDs. These are we have defined different pins of the LCD. Then these are 3 functions which are used in our header file. First of all, we have this function is used to initialize our LCD. This function is used to control our LCD, and this function is used to display different values on our LCD. This function is used to display string on our LED. So this is our header file of LCD. Again to the main function. In this main function, first of all, we have declared port C and port D as output ports. Then we have declared in all these commands, we have declared this Arduino as slave Arduino. So this is our register in which this is an interrupt, SPI interrupt enable. In this register, first of all, we have to load this pin. For master, we have to make this pin high, and for slave, we have to make this pin low. And these two pins are for our prescaler mode. We are selecting 128 dividing our frequency by 128. So we are selecting as 128 prescaler. We also have to make this bit high for SPI communication, for making it as SPI communication. Then we are again moving on to our slave code. For master, we have made these bits as output. For slave, we are configuring them as inputs. This is the only pin which we will declare as output for slave function. This is our setting as slave, because as you know, we have set that bit as 1 in master. For slave, it should be 0. Then these are the division by clock by 128, and then this one is used to enable SPI communication in our control register. Moving on, so these are two variables which we are using to have a loop. Then this is a function in our LCD header file to display the string. So now moving on to the while function. In this while function, first of all, there is a condition. In this condition, actually we will send a string. The string is of 5, so we will repeat this loop for 5 times. This is a function in our header file, and this is a function to control the LCD cursor. Same as here we have sent temp, and here we have sent distance, and then at this condition will make it wait until the whole data has been sent to the LCD to display. So this is the last to ensure if the whole data has been sent to the LCD to display. And at last we are incrementing our two variables so that we can go out of this loop. So this was our slave function. Now we will move to our Proteus simulation. So this is our Proteus simulation circuit. We'll run it. So as you can see, LCD is displaying temperature and distance, and motors are also working. So these are our motors which are interacted with our IR sensors. Instead of IR sensors, we are using switches as mentioned in our problem statement. So if we are on switch number 1 left, then you can see that this, as we are having a delay, so as you can see, the left one is working. Now if I on the right one will start work after its delay. So the right one has start working. Now if I make all of them as 1, it will move forward, which means it is moving forward. Both motors are working. And if I make all of them as 0, it will stop. So this is our function of motor. So coming to our distance sensor, as we increase the distance near it, we will see a message on, we will increasing it, and here is a message of obstacle ahead, and our both motors are stopped. So this is our Proteus, in which this temperature sensor is is giving input to the master Arduino at pin 85, and this distance sensor is giving input as AD0. After that, we are having a slave Arduino, which is used to display different messages and values of temperature and distance on the LCD. We have a motor driver which is working, and motor driver pins are also initialized on the master one. These are the pins which are initialized pins of motor driver. So this was our Proteus circuit, and as you can see, it is in a running form. So now we have moved on to the basic block diagram. So this is our basic block diagram with one microcontroller. For one microcontroller, we take some input from the sensors, and we have a power supply and a crystal frequencies of a microcontroller, and a reset circuit is also there for microcontroller. Then we have a H bridge in our motor driver, and then it will decide whether we have to move whether the left motor should work or the right motor should. This is our basic flow chart of our sensor system, in which first of all line follower report. This is a basic flow chart of that. First of all, we take sensor input from IR sensor for line detection, and then microcontroller decides whether in which direction we should move, and it gives its output to the motor driver, and motor driver then gives the output to the motor whether the right motor should move or left motor should move according to the input given by the sensor, IR sensor. Then here is a project development flowchart. It is a recycle type flowchart, in which first of all we judge the environment. First of all, we judge the environment. In which environment? Actually, the IR sensor are used to judge the environment. The black line is our environment. Then it collects the information. IR sensor gives the information to the microcontroller, analyze as per coding going on it. Then as our microcontroller is coded, so it will analyze its function according to the input given from the sensor. Then it look for uncertainties of mistakes. There are many uncertainties. The environment is very uncertain, so the program should look for these uncertainties for the better and improved function of robot. So this was our project development flowchart. These are our hardware components. We have used IR sensor, microcontroller at Mega 238P, then a motor driver, LCD, temperature sensor, and a sonar sensor or a resistance sensor. Then we have a circuit explanation. Here a very basic description is given, which we take input from IR sensor, and then it is given to the microcontroller, and microcontroller act as the input given. And here is the basic block diagram. So this is our block diagram, in which we have used serial peripheral interface serial communication to communicate between these two microcontrollers. First one is at Mega 2560, and second one is at Mega 328P. At Mega 2560 is used as a master, and the second one is used as a slave. Master, it is used as a master as it has many pins, so that we can connect in sensors to it, multiple sensors. So we have connected a LM35 and a distance sensor. LM35 is giving input to the master, and distance sensor is giving input to the master, which is then given to the by serial communication. The values of the values of input given by these sensors are given to the slave, which are displayed on the LCD. The movement of the report. For movement of the report, the three IR sensors are giving input to the master, and master is deciding whether which motor should be enabled. So master, our master Arduino is giving output to the motor driver, and motor driver is driving left and right motor. So this is our basic block diagram. This is our Proteus circuit, and then there is our software tools we are using at Mega through we are using Admin Studio 7 for software. So this is our main flow chart which we have made according to our code. First of all, we will start, and then we will define crystal frequency, then we will define include libraries, then we will define pins, declare functions, declare global variables, then declare functions of PWM. Then we will come define functions. Actually, first we will declare functions, and then we will define functions, and then we will come to the main function. In main function first, then we will call the master function, call interrupt, and initialize, call this function of initialize PWM. Here, as I have numbered it at flowchart number 5, so now for call interrupt function we will move on to the flowchart number 5. Here we are having our flowchart number 5. So first of all, we will initialize INOT, this is our function name, and then we will set this register interrupt occur at, set this register such that interrupt occur at any logic change, and then we will set our mask register such that enable interrupt external interrupt. We will set our mask register as interrupt enable, external interrupt enable. Then we will initialize PWMs and timer, and for that we will move to the flowchart number 4. Flowchart number 4 is this. First of all, we will set compare register, then we will set PWM fast mode, and we will set the prescaler mode. As we are using no prescaler mode, so we have set as no prescaler mode. Then we will enter the while loop. In while loop, first of all, we will call our function of distance, read distance. So for this function, we have to move to the flowchart number 3. So this is our read distance function. Read distance function, then we will call our ADC initialize function. First of all, we will initialize our ADC, then we will control our ADC, then start conversion. We will have a command to start the conversion from analog to digital conversion. Then we will wait until the conversion is completed, and we will clear the flag ADIF flag as the conversion is completed, and then we will send the integer to string, and then we will have a check function. Check function, if distance is less than 20, then it will display as obstacle head and it will stop the motors, and otherwise it will send the value to the slave. So this was our distance function. Then we will to the main chart. So main chart, then we will have our temperature function as our code as so this is our second number chart, which will give us the temperature. For temperature, same, we have initialized our ADC, then we have our ADC control, we have initialized our ADC control registers, then we have start conversion, wait until the conversion has been completed, then clear the flag and convert the integer to string, and then send it to slave. This was our temperature function. Then we will set a duty cycle. So for duty cycle, we have to move on to flowchart number 7. So this is our flowchart number 7, in which we are setting the duty cycle. We have set the duty cycle. First of all, we have taking speed as input. Then we have our decision function. If speed is 0, then duty cycle is set as 0. If no, then it will move on. And if speed is 1, then duty cycle is 20. If speed is 2, duty cycle is 50. And similarly, if speed is 3, duty cycle will be 100, and at the end, and then it will be ended. So again, moving on to our main function, then there we have a movement functions. Movement function, for movement functions we have to move to the flowchart number 6. This is our flowchart number 6 for movement function. First we have to select the duty cycle which we have selected. Now this we are taking input as duty cycle in this function. Then if the middle sensor is enabled, then it will move forward. If the left sensor is enabled, then it will move rightwards. And if right sensor is enabled, then it will turn left. And if all are 0, the robot will stop. So this is our moment function, and at last it will end the program. So this was our main function, which have other functions which I have mentioned in different flow charts, and I have numbered those flow charts here. So now we are moving on to the basic calculations. There are only 3 calculations for temperature sensor. There is a formula. It will take results from the ADC, and it will divide by 2.1 plus 1. Then there will be a distance calculation. Distance calculation will be the same except this one. There will be no plus 1. And then there will be a duty cycle. For duty cycle, there is a so here we will calculate motor speed. Motor speed is calculated by duty cycle divided by 255 plus 5 volts. So for 55 duty cycle, we have calculated the motor speed for 155 duty cycle, and for 255 duty cycle, we have calculated the motor speed. So all the points that are mentioned in the problem statement has been covered. I hope that I have elaborated all the points in a way that is easily comprehensible. Thank you for watching.